Look at it, the maximum number of valence electrons any atom can have is 8. The minimum number is 1. Okay? Again, this should be review. All right, so this is something new here. We're going to talk about ions here. And again, the most important thing to remember, the number of protons determines the element. The key with this is that if it determines it, we can't be changing it. So we will not change the number of protons. Okay? Remember, protons have a positive charge, neutrons have no charge, so we don't really care about them when it comes to ions, and electrons have a negative charge. So because of that, if I can't change the number of protons, and I want to get something charged up, then I want to look at the number of electrons. So the number of electrons are going to determine the charge. And this is where ions come in. Okay, and so we'll define that here in just a second. The other thing, all atoms are blank charged before they react. So if you think about it, before there's any reaction, they should have the same number of protons and electrons. So protons equals electrons. If that's the case, it doesn't matter what element we have, all atoms are always going to be electrically neutral. So all atoms are neutrally charged before they react. Okay, so what an ion is, by this basic definition, ions are atoms that have gained or lost electrons. Now, this shouldn't just happen. There's got to be a reason for things to happen. So the reason why atoms gain or lose electrons are to become stable. So being neutral does not mean you're stable. If you look at atoms like fluorine, it's very unstable. It's so unstable that if it reacts, it'll react with almost anything, and it will do it explosively. So you have to be extremely careful. If you just had some fluorine sitting around and you started trying to mix it with things, you're going to have an instant explosion, and it's going to be pretty big. So you're going to lose some fingers and things like that if you're working with fluorine. So we want to understand ions and kind of how they work a little bit. There are basically two types of ions. There's cations, and there's anions. And if you look at it, we've got ions in both names, so you just kind of have to remember the beginnings here. So cations are positively charged. Misspelled positively there, apologize for that. So you can just remember positively charged ions. The other one, obviously, is going to be negatively charged. So you can put a negative sign there. Ions. And a way of remembering this is that anions, if you look at it, it looks similar to the spelling of onions. Onions will make you cry, and that's negative. So you can remember onions make you cry, that's negative. So that's a quick, easy way to remember that. If you want to remember cats are positive, go for it. I don't agree with that. I think they're the most evil animal on earth, but that's what we have to work with. So anions are negatively charged ions. So with this right here, how do we get that? Well, all atoms start off neutral, right? We have the same number of protons and electrons. If we're going to make an anion, we can't change the number of protons, so we're going to gain electrons to do that. And that's going to give us a negative charge. So if I was working with fluorine, which has an atomic mass of 19, an atomic number of 9, if I wanted to make this an anion, I would add an electron. So this is right here is showing my charge, and it's telling me that I have gained an electron. Cations, on the other hand, are going to lose electrons. And you basically would have the opposite for charges. So let's look at these just a little bit here. First thing we want to do here is identify if these are cations or -1. This is going to be an anion. We know it's an anion because of the negative charge. +3, we have a cation for aluminum, cation here for calcium, anion for sulfur. Next thing that we need to do is how many electrons did the element gain or lose? So if I have -1, remember protons are positive, and electrons are negative. So if I look on the periodic table, I find iodine. If you look in the periodic table, iodine has an atomic number of 53. So I've got 53 protons, and I should start off with 53 electrons. So if I add that up, basically I've got a plus sign here, a minus sign here, I'm going to get 0. If I get 54 electrons and 53 protons, so plus and minus, I'm going to get negative 1. So I am going to gain an electron. So it's basically the opposite of what the sign is showing you. If this is negative 1, I'm going to have to gain 1 electron. So if I'm looking for my total number of electrons, again, I would start with 53 when it's neutral, plus 1 gives me 54. Okay, this one right here, when I have a plus 3, that means I lost 3 electrons. So if you look for aluminum, aluminum's number 13 on the periodic table, so I should have 13 when it's neutral. But because I lost 3 electrons, I'm going to subtract that, and I get 10 electrons. So there's my total number of electrons, total number here. If I come over here to calcium, calcium is number 20, so it should have 20 electrons to start with. I have a plus 2 charge, so that means I got to subtract 2, so I'm going to get 18 electrons total. Sulfur has a minus 2 charge here, and if you look for sulfur on the periodic table, we have 16. So 16, that means I have to gain 2. So I'm going to do 16. I'll just erase that really quick here so it's not a confusion to you. 16 plus 2 gives you 18 electrons. So always kind of keep this in mind. Ask yourself, how many electrons do I start when I'm neutral? And then am I going to gain or lose electrons to make this charge? If I gain 2 electrons, I'm going to get this particular charge. So if you keep that in mind, it's a fairly simple process. Okay, here's a little bit more expansion, showing you the full isotope. So I know my atomic mass, exactly what it is. I don't have to round this periodic table. Here's my atomic number. So atomic mass, atomic number, and again, this is your charge. That's how many electrons we gained and lost. So if I'm going through here, we can, if it's a positive, we know it's a cation, so we've got several cations. Over here's another cation. Anions are negative ones, so we got several negative ones. How many protons do we have? Well, that's a nice thing. It's already given to us. So I got 11 protons. To get neutrons, I'm going to take 23 and subtract 11. Remember, that's equal to protons plus neutrons, and this is equal to protons. So if I subtract that out, all I'm left with is neutrons. So I'm going to get 12 neutrons. And then for the electrons, I'm going to start with 11, but because I have a plus 1, I got to do the opposite. So minus 1, I get 10 electrons. So there's my answers to that. Protons here, I have 9. Neutrons, I'm going to subtract 19 minus 9 to get 10. And then for the electrons, I should start with 9, but then because I have the minus 1, I have to add 1 to it. So I get 10 electrons. 27 minus, or protons, I'm going to get 13. Neutrons, 27 minus 13 will give me 14. And for the electrons, I've got 13. Plus 3 gives you, means I have to subtract 3, so I'm going to get 10 electrons. When you get something like this, then I'm not telling you much information. I'm only telling you the charge. So you'd have to look at your periodic table to get its mass and everything else. So I'm going to go ahead and round the mass. It's 35.4527 on the periodic table. I'm going to round that to 35. And it has an atomic number of 17. So now that I know that, I can go over here and I can start working with these a little bit. So protons, I'm going to get 17. And then I'm going to take that 35 minus 17 to get my neutrons. So I got 18 neutrons. And then my electrons, I've got 17 to start with when it's neutral, plus 1 because it's negative, and it becomes 18. So pretty simple there. The only other exception we could have is something like this, where I give you the atomic mass. So I'm telling you the exact atomic mass here, but I'm not telling you the atomic number. And that's okay, because magnesium's atomic number will never change. So I can look it up, find 12, and go through the same process that we've been doing. Okay, so here's a short video working with this. So go ahead and it's basically a quick review. I'll show this here at the end, and so it'll be